Okay, good morning. Can you all hear me okay? Good stuff. Before I get started, can I just have a quick show of hands? So how many of you guys and gals are sort of pen testers or working in red teams? Blue teams, SOC analysts, that type of thing? And security sort of managers and the like? Okay, excellent. So we are first-time presenters, so bear with us. But I'll give you a quick bit of an introduction into what we're about and who we are. So that's me, and as you can tell, I probably look a lot better in black and white. So previous background, quite heavily into sort of infrastructure, sort of various roles. Fairly new to InfoSec, so a couple of years in now as a penetration tester. You're probably thinking you don't want to listen to me talk for a good 40 minutes, so you'll be happy to know that my colleague here, Jon, will be taking over second of the presentation. So, as you can see from Jon's photo, he's not much better looking in real life, so, you know, bear with him. So Jon has much of a similar background to me, so we are we've done sort of similar work in the background. Jon is now working as a security architect, sort of specializing in IoT. So he is going to be very happy to field any questions you have around any complicated IoT issues. So feel free to you know, touch him on the shoulder and when you're out in the hall con and make sure you make it as difficult for him as possible. Also, because he's working in IoT, he is single-handedly sort of saving the internet. So again, feel free to sort of congratulate him on that. Last boring slide is a little bit of a disclaimer. So obviously our words and views and thoughts are our own. We don't have any affiliation with the companies that we work for. And obviously if you do decide to go and use the work that we present here today in your places of work or in systems that you may come in contact with, then obviously the usual is be responsible. So if we will get into what we're actually here to talk about. And so what is a Pikey? So as you can see from the executive summary there, really, it's a physical pen testing device. And we've designed it for the extraction and reuse of credentials. So the way we look at it is we wanted to design something or make use of something that was in essence a tool that you could come along to a locked computer, Windows 7 in this case, in a corporate environment, plug it in, wait a few, 60 seconds or so, and as if by magic, it would unlock. So that is exactly what this talk is going to be about. So there's going to be a little bit of background about how we've got to this point. So there will be some sort of R&D slides and kind of get you into the mindset that we had whilst we were developing it. And hopefully at the end, you can obviously download the code yourself from GitHub and have a go at making one. So the basis for this work, and you can probably, if you cast your minds back to September 2016, you may remember seeing an article from Mubix, who's Rob Fuller. So he had demonstrated that by plugging in a USB network device into a Windows 7 machine, or Windows 10 machine for that matter, Windows naturally then starts to trust this device and proceeds to send traffic out of its interface. So in essence, it gets bumped up in the routing table, and all of a sudden, all the network traffic that is going from the PC at the time will quite happily go across this new network interface. So this is kind of the basis and the key to the work. So we built on this, and there's been other similar attacks since then. So you might recall Poison Tap. But this one seemed to sort of stand out to us as the one that's most relevant to a corporate environment, so sort of the natural thing that we see in the engagements that we do. So just to give you some background on how this works, so obviously you guys that are pen testers and work in red teams, you're probably more than aware of how this attack worked, but for others we'll just go through some of the detail. So Rob took a USB LAN armory, which is in essence just a USB key with some compute module on it. This emulated itself as a network adapter. Happy days. Windows naturally saw the network adapter and was quite happy to install it. As I said earlier, Windows tends to prefer the newer and faster connections. So again, it was more than happy to accept this and proceed to send traffic out the interface. The real key bit was that Rob had installed Responder, which is a tool from Spider Labs. So again, pen testers, Red Team is probably more than aware of what Responder does. But in essence, it is going to poison any name resolution request that it sees. So in a typical engagement, you might start it on a LAN segment and then wait for a period of time. So what Responder is going to do is it's going to look for any name resolution requests that come across the network. So your normal net bias, link local. And then it was going to proceed to, in essence, put its hand up and go, yeah, I'm that guy, I'm that host. So it looks for people that, perhaps fat-fingered an intranet address or a file server address. Once it's spoofed that address, it then proceeds to emulate the service that the original request was for. So for SMB services, HTTP, SMTP, Responder has a whole library of services that it will emulate. And then it will proceed to take part in any authentication protocols thereafter. So for NTLM, for example, it will quite happily do the challenge response, start to store the credentials, and then end the communication. So in this instance, it doesn't have to worry too much about looking for that name resolution traffic because it's all coming out of that interface anyway. And again, in the original attack, so after the device had received some credentials, so Responder happens to store all these credentials in a database that it runs. So once it has these, the device just shuts down. And then it's down to the person that's running the attack, the attacker, to then take it away and crack these credentials. So all in all, it was quite simplistic, and we've elegantly summarized the process here. So USB device, Windows machine, credentials. And that is as simple as it got. So at the time, I think Rob got quite a lot of press for that because it was so simplistic. He summed it up in his own words: USB Ethernet plus DHCP plus Responder equals creds. So again, he decided to use some quite expensive equipment for this. So he used USB Armory at the time. He also demonstrated that it could be done on a Hat5 LAN turtle. The one slight caveat with the process is it relies on the Windows machines being quite chatty. So what we found, certainly when we were testing this, is that in your sort of typical coffee shop scenario where you might find a locked machine, you're not going to have so much success. It's largely based around corporate environments where clients are locked, they're already sending traffic, they might be trying to update their email or browsing an intranet site, etc. He also discovered it worked on Windows 10 and earlier, and as you'll see a little bit later in the presentation, that's kind of been caveated now, but still 100% works on Windows 7, which is great. So we had a go at replicating this attack. So the USB Armory was Rob's weapon of choice, so we thought we'd give this a go. At 200 quid a time, it's quite an expensive device. It's not so easy to get going. And we also found that when you plugged it in, fundamentally Windows needed to get some drivers installed. And again, because we were looking to target this in a corporate environment, as you're more than aware, it's not going to reach out to Windows Update with proxies in place. UAC is going to obviously block it, so it wasn't quite working to plan. And we felt both of those issues kind of made it a low risk. So, but we thought we'd have a go at maybe trying to get the cost down at least. So I think there's similar work out there as well around this, but we in essence bought a Raspberry Pi Zero. We managed to get all of Rob's work replicated onto that. So the original work was really based on just having a couple of services start when the device boots up. So it was quite easy to replicate that onto a Pi Zero. With the Pi Zero, however, we still had the emulation issue, so drivers were still required. And the one thing that really frustrated us was the fact that fundamentally, even on the Armory, the feedback from the device was quite minimal. So you would, in essence, just see a little LED flashing. It might turn off. It might flash longer. We couldn't really tell what the device was doing at any point in time. Sometimes Responder could take up to 3 minutes to grab some credentials. Sometimes it might happen quicker. So we found that constantly unplugging and plugging the device in ended up corrupting the SD cards a lot of the time, and we had to spend quite a bit of time rebuilding them thereafter. So we got thinking that we could try and make this a little bit better. And this is kind of where we get to with the project and the talk as it is today. So whilst snagging the creds is great, it still means that we have to take them offline to crack them. So whilst you can use it as a bit of a harvesting tool, whilst you're in front of the machine, we got thinking, well, perhaps it's better if it just unlocks the machine, because you already made the effort to get to that point anyway. So the whole aim for us was to try and make something that was usable in essence, so overcome those initial hurdles that we saw with the driver issues, give it some better feedback, make it cheaper. No one really wants to spend 200 quid on a USB armory every time they want to do this, especially if you're going to lose it. And also make it plug and play. So again, we don't really want to have to plug in the device and tinker with the code every time you use it, or that sort of thing. So really, in essence, we wanted to simplify it. For some reason, Jon really loves this slide, so I left it in. So we got thinking, and we tried to break it down into those sort of component parts. So the user feedback, making it usable, driverless installs, and plug and play. So we stuck with the Pi Zero, partly because it's immensely cheap, and also it had a few perks that come with it. So as you can see on the image there, it doesn't have a lot of interfaces, but it does have a USB port, and it does have a power port. The one good thing is that it takes its power from either, so it can be powered over the data port. So that means you don't have to carry around a separate power supply, and it kind of performs as it would do in the original attack. So you just need an on-the-go cable, and away you go. The other, and probably the most important part, is that the device can be put into host or slave mode. So for a USB device, when it's in, for a device like this, when it's in host mode, it will quite happily receive connections, so from keyboards, mice, etc. When it's in slave mode, however, it can then do the emulation stuff. So because we were looking to be able to do feedback, so reuse the credentials that we had snagged and cracked, we needed to be able to switch it into that mode as well. So we emulate network adapters, and we wanted to emulate a keyboard so that we could type it back in. So that's quite a key piece to the puzzle. Obviously, it's small, tiny, and it's designed for a whole community of people that like to design wonderful cases of all various colors, sizes, and whatever. So wrapping it in a case and putting it in your pocket made it quite ideal. It comes with its own strong sort of community backing as well. So there are various Linux distros for it. So again, getting it installed on a micro SD card is really no problem at all. And lastly, the most, again, kind of an important piece to this is along the rear side of it, for those that you don't know, it has these GPIO pins, which are just input and output interfaces. But because it's designed for a community of people that quite happily like to tinker, it's designed to have various motors, sensors, and other devices plugged into it. So for us, we got thinking that that would be a good opportunity to be able to give it some feedback, which we'll touch on a little bit later. So the downside of the Pi Zero is, however, we wanted to crack the credentials and play them back. So as you can imagine, doing any sort of cracking on a single processor, 1 gig ARM processor with 512 meg RAM is not going to get you very far. We wanted it to be, as the title suggests, like the movie. So we didn't want you to plug it in, hang around for 5, 10 minutes, 2 hours, 3 hours, whatever, make a cup of coffee. We kind of wanted it to be as instantaneous as possible. So although there are, and again, as you'll see in the demo, there's a little bit of a delay in it, we got the time right down by not relying on the Pi Zero doing the cracking itself. So if we couldn't crack on the Pi Zero, we got thinking about where we could do the cracking. And obviously, as again, some of you pen testers and stuff will know, there's various libraries of pre-computed hashes out there. And we thought that would be a good place to start, because at least then we'd get some immediate response back. So we could either say this hash was a simple password, and it would get cracked immediately, or nothing, and we can just shut the device down and move on. So we did find a problem with using that approach, however. So this is quite a busy slide, but as you can see up there, Responder quite happily emulates all those various services, as I mentioned earlier, so HTTP, HTTPS, etc. And what it tends to do is, because it's performing the challenge response for those services, for an NTLM perspective, it doesn't just store a plain hash, it stores a salted hash. But the good thing is we know the salt, because Responder is doing the challenge response, so Responder is in essence sending that initial challenge, and the salted hash thereafter is a mix of the domain, the user, and that challenge. So we have all the information we need, but the downside is the online crackers typically prefer unsalted hashes. So I guess some of you have probably used CrackStation in the past, and you can see down the bottom there, it's quite happily crack NT and LM passwords, a bit like the typical output from the SAM table, but it won't help us in doing those salted hashes. It's just another example of another online cracker. And again, similar thing, quite happily do the NTLM and LM straight out of the SAM, but not what we were hoping to crack. So we wanted to obviously do it ourselves, and we decided this. And also, because the client's data that we're working with, it's sensitive, it's password data, we wanted to put it into an environment where we were in control. And obviously, the applications like Jon and Hashcat, Jon the Ripper, they will quite happily crack passwords, these salted hashes all day long. We can control the word lists, so that is exactly what we wanted to do. And to do that, as you can imagine, we just spun up an AWS EC2 instance, doing it on a little bit of a shoestring budget, so we only went for the cheap T2 micro option. But as you can see, it's already doing it 8 times faster, the cracking, than the Pi0 itself. If you want to scale that up, and Jon will touch on this a little bit later as well, then the options are there. But there is one snag. Now, before I put this next slide up, for some of you in the know, bearing in mind when we did the initial research for this was back in 2016. So at the time, there was no Wi-Fi available on the Pi0. And this has probably got us thinking why no one's bothered trying this before, because as I'll come on to in a minute, you'll see why it was quite such an arduous task to try and get it working. So we had some options for the wireless. First of all, most people seem to suggest, oh, just plug in a USB dongle and away you go. So the downside to this is, as I said before, we either can run in host mode or slave mode. As soon as you plug in a USB dongle, it becomes host mode, and then you can't do the emulation of the keyboard on the network adapter. And we've only got one USB port, so that's not really an option, and we'd have to carry a battery around to try and power it. On the far right there was various sort of serial hats that you can get to plug on top of the USB, the Pi0. Again, these were brilliant. However, they were kind of reliant on the old school AT commands. You'd have to write your own packet, making the whole communication a little bit tricky. And then to the real extreme in the middle, we had those people that like to do soldering and use various amounts of tape, and that just horrified us. The whole point of this was we wanted to make something that was reproducible, and we didn't want to come along and say, here's a brilliant device, however, if you have 20 hours free, you can do some soldering and you'll be away. So amazingly, it took quite a lot of research to find this. But there was a device, a Kickstarter project, and this Red Bear hat, which gave us, in essence, Bluetooth and wireless capabilities. So it didn't immediately jump to the top of any internet searches. However, the benefit of this is it uses all of those GPIO pins we mentioned earlier. So great. We weren't using them at the minute. And it comes pre-soldered with the headers. So again, no real need to do any soldering. It comes with a custom EEPROM as well. So it means when the device boots, it pre-configures all of the wireless details. So there's no need to do any driver installs or anything funny. You just get a WLAN 0 presented straight out of the box. Soldering, however, still caused us some issues. I don't know if many of you out there like to do soldering. Soldering 40 pins at a time for a novice like myself and Jon is a stressful task, certainly not therapeutic. So we went to try and find something that would be a little bit easier and a little bit more reproducible. So we did come across these wonderful solderless headers. So I find using a hammer much more therapeutic than soldering. So we thought that was great. So you put these in place, and you just hit it with a hammer, and away you go. So in essence, that gave us our wireless capability. So we had our Pi Zero, our solderless headers, and our Red Bear hat on top. The Red Bear was a little bit expensive, so it kind of hit our budget. We wanted to try and keep the cost down, and it had to ship from Hong Kong, so we had to wait, the best part of 4 weeks for it to arrive. The next thing we wanted to look at, and as I mentioned earlier, is trying to improve that user feedback. So having one little LED that blinks isn't great. We didn't want to make this like a school project, so we didn't want to then have a whopping great big LED just soldered on and hanging off the side. So we tried to have a look a little bit into the other resources available. And like I say, Pi Zero and the whole Pi community, there are so many customizable interfaces and modules. So we found that we could get a nice little LED matrix to sit on top of the GPIO pins, in essence, and that would give us some feedback. So, and not only just an on and off feedback, we could stage it so we knew exactly where the device was at any point in time. Fundamentally, that helped us with the whole debugging as well. So when we were building the thing, we knew exactly what stage we were at. So at this point, I'll leave this slide up here just for you to ponder, but I'll hand over to Jon, who will take you through the next half of the presentation.
Thank you very much. Okay, so what you're looking at here on the left-hand side is the GPIO pinout for the Red Bear device we were using. And on the right-hand side are a couple of examples of LED display boards. Now, you might be able to see there's actually a crossover between the two. There are a number of pins required by the LED displays that are also in use by the Red Bear already. And we found this all over the shop when we were looking for suitable LEDs. Stuff that was easy, just plug and play, just didn't want to work. They weren't compatible. So with a bit of research, we found two devices that would kind of fit the bill. The first one's called the Blinked. It comes with 8 RGB LEDs. It cost about £5 to buy, so it was nice and cheap. It comes with a Python library, so it was easy programming for us. And it comes on a header that just essentially just sits straight on top of the Pi. Okay, so here it is in action. The astute amongst you will notice that it's not sat on top of the Pi. And that's because when we got it, we realized that a couple of the pins required for the Blinked were actually in use by the Red Bear already. So quick solution was to solder a couple of wires on the back of the Blinked, map those to unused pins on the Pi, and then just remap the whole lot on software. So the pros of using the Blinked was that it was cheap, it's only £5, and those 8 LEDs gave really good user feedback as to what was going on. The downside was those 4 pins soldering on made it wasn't quite as plug and play as we wanted it to be. And you had to wedge the Blinked in between the Pi Zero and the Red Bear to keep it in place. It just wasn't the best solution. So the option 2 was a scroll fat. This comes with 55 LEDs. They're all white, they're not colored, unfortunately. It costs twice as much as the Blinked, it's £10, but again, comes with a header you can just plonk on top of the Pi, and again, comes with the Python library for easy programming. Because it's got so many LEDs, it also means you can give text messages to the user, so we can say we're at stage 1, or responders running, or we've got cred. Go. So here it is in action. So the top left-hand image you're looking at is the Pi Zero on its own. The top right-hand one is the Red Bear with a couple of extra long headers called stacking headers soldered on. The bottom left-hand image is the scroll fat, and then the bottom right is everything connected up together with my really poorly shoddy wiring. So the pros of using the scroll fat was it literally just sits straight on top of the Pi. The GPIO pins required were exact match, so it goes straight on like Lego. And because we had those LEDs, like I mentioned, you can give text feedback to the user. The downside was, between all the soldering required for everything, that's 120 pins I had to solder, and those stacking headers were a real pain in the backside. And because it's £10, it's twice as expensive as the Blinked. So, quick recap where we are so far. We've now got a cheap device to run the attack on. We've given it networking capabilities. We've got password cracking up in the cloud. We've now got user feedback through LEDs. Well, we've still got that issue that Trevor mentioned earlier with the drivers still being required, which really caused problems in a corporate environment. So we fixed it. So straight off the bat, the Pi will present itself as a generic Ethernet gadget, and Windows doesn't have drivers for that built in. But a bit of Googling and a bit of messing around, and we found that, in fact, if you just tweak the vendor code and the product ID, Windows does have drivers for an IBM device built into it. So if you presented that IBM device instead of the generic gadget, Windows has the drivers and will just pick it up and run with it. And the last piece of the puzzle should have been the easiest one, actually. So to type in the creds back into Windows, we need to emulate a keyboard. And weirdly, the modules required to emulate a keyboard are not in the kernel that was in use by the Pi by default. So we had to roll our own kernel, and we are, say, not Linux guys, so that was interesting. But after that was fixed, the Pi just plugs and plays, and Windows picks it up as a keyboard. So we were done. We had 2 devices. They worked perfectly. The password cracking worked perfectly. We had a small amount of code polishing to do. We were ready to release to the world. And this was start of this year, start of 2017. There was just one thing. The Pi 0W came out. So Feb 2017, we were just polishing everything off, and this got released. For those that don't know, it basically takes the Pi 0 and gives it wireless capabilities. Because we now have wireless capabilities, we don't need to use specific LED devices to give feedback. We can use whatever we want. And because it's got wireless, it updates the kernel, and that kernel broke our keyboard module again. Have you ever worked on a project for 3 months, loads of time and effort and research into it, and then someone comes along just as you're ready to release and just kind of kiboshes it all over? Yeah, we were thrilled. New technology. OK, so introducing the new Pikey, based on the Pi 0W. We polished it all up a bit, so it's now got installers for the Pikey itself and for the server side for the password cracking. We've standardized on the blinked because it does give really good user feedback. We don't need to do any soldering of fiddly wires anymore because all the pins are freed up. We can just stick it straight on top. We have left the code in for the scroll fat if you want to use that, which is the one I chose. Right, OK, so quick recap, how everything works. Firstly, you plug in the Pikey, which powers itself up. The Pikey will then connect to your phone or whatever wireless network you've got to make sure it's got a cloud connection. It then installs itself as a network interface and waits for Windows to give it some creds. Assuming you get some credentials come out of Windows for some way, the Pikey chucks it up to our password cracker up in the cloud. That churns away, and assuming, of course, you can crack the password, that gets sent back to the Pikey. The Pikey then removes itself as an Ethernet device, reinstalls itself as a HID device to Windows, presses Control-Alt-Delete, and types the password back into the user on the lock screen, hopefully unlocking it. Now, I wasn't brave enough to give a live demo today, so we've got yes, we've got the devices with us, so we can show you later. But we've got a video in action. OK, so normally takes about 20-odd seconds for the Pikey to boot. When it does, a couple of LEDs will come on. So it's booting, connecting to your Wi-Fi to test connectivity. So responder sat in the background just waiting for Windows to give it some creds. The 4th LED will light up when responder gets some creds. OK, so we've got some creds. It's now going to send it off to our cracker up in the cloud. And once those have been cracked, it'll be sent back to the Pikey. Pikey is now installing itself in HID mode. And you'll get a few more LEDs, and the machine should unlock itself. There you go. OK, so that was a demo. How does it usually take us? So we found it normally takes about 60 to 90 seconds for the whole attack to work. A large chunk of that is the Pi booting, and obviously a large chunk of that is the password cracking up in the cloud. So we can probably optimize that slightly. We did have to introduce some artificial delays, actually. So when you first install it, Windows has got to pick up the drivers, and it's got to install them. On really slow machines, that can cause problems, so we had to put in a kind of 10-second delay for that. And again, we found some machines when you type in the Control-Alt-Delete, it takes half a second or so for the machine to pick it up, so we had to put some delays in for that. So one of the things I said earlier was, and Trevor touched on actually, is that to speed the attack up, at the moment we're using Jon the Ripper for doing the password cracking. You can swap it out and use Hashcat. Amazon now support GPU instances, and Kali comes with it out the box, which is what the server's based on. So if you want to do a bit more cracking, spin up an EC2 P2 instance, and that'll make the password cracking a lot quicker. Fundamentally, the Pikey is just based on password cracking. It just takes a password, cracks it, and returns the results. So like any engagement, if you optimize your word list beforehand, if you're going into enterprise, the chances are you've got 8 characters or more and complexity turned on. If you optimize your word list, you'll get much better results. So we had very specific use cases when we actually built this. We figured people would be using it for social engineering engagements, maybe for internal testing. You might take it between different clients. There's a high probability that you're going to either lose the device or the internal team's going to catch you and are going to snag it. And we really didn't want corporate creds just kind of floating around a device for someone to grab. So when the Pikey first boots and when it shuts down, it clears all of its logs. So nothing's stored on the device itself. For passing creds between the Pikey and the cloud and back again, we use SSH. And the keys for that are generated when you first install it, so the unique keys for yourself. The server side, though, the password cracker does store everything passed to it. And the rationale behind this is the Pikey is really meant to be used on a kind of a couple-of-minute engagement. You find a locked machine, you stick it in, you crack it, or you don't, and you kind of walk away. But it could well be that you're on a 2 or 3 day engagement, and those passwords can be reused at a later date. So you'll send everything up to the cloud cracker. If you can't crack it there and then, doesn't matter, move on. But it could well be that you can spend a lot more resources that evening, crack the password, come back on day 2 and use those in a different manner. So, okay, in the real world, realistically, this only works on Windows 7. The original attack by Mubix worked on Windows 10, but Microsoft patched it, and everybody keeps their environment patched, right? So Windows 7, but quick show of hands, how many people use Windows 7 in their enterprise? Yeah, quite a few. So it's going to work basically everywhere. Again, in the real world, the machine has to be fairly chatty. If you take a newly booted machine and lock it, it'll take a long time to get any creds out of it. If you've got a standard machine with Outlook running, a lot of background services, you'll get a lot quicker responses. And also, you need a Wi-Fi connection to get up to the cloud. We found on some engagements, either the clients won't let you take your phones in, or you just don't have a 4G signal, in which case you go nowhere. So when we tested this, we've got about a 20% success rate. And if anyone's done any real password cracking in an enterprise, that kind of sounds about right. If they've never done a password audit of their AD, 20% is kind of the normal hit rate. As I said earlier, if you optimize your word list, chuck a lot more power behind it, you get a much better success rate. But we have found, in some places, technologies in place that accidentally prevent the Pikey from working. Because when it's first inserted, it comes up as a new network interface. And we found that some enterprises have got firewalls that automatically come up if they don't recognize the network, or VPNs that automatically try and connect, and that kills the attack dead. I inserted this slide at the last minute. I'm kind of regretting it now. Right. So up to this point, we talked about the red teaming aspect of it. How do you protect against the Pikey? So one solution is endpoint protection software. If you define exactly what you can and can't connect to your enterprise, which USB devices, like only specific keyboards and mouse, that kills this dead. If you haven't got endpoint protection, group policy comes with it out of the box. You've just got to configure it. If you haven't got that, or as well as, essentially the Pikey is just a password cracker. So strong and repeatable password audits will make a big difference. NIST have actually just released a new standard for password you can kind of shove in your enterprise's face. But if you can't do that, you could force all users to log off when they walk away. You'll be very friendly for that one. Superglue the USB ports. Well, my favorite, give your enterprise MacBooks with the stupid USB-C connectors, and hope they don't have an adapter when they come on site. OK, so last slide. If you want to have a crack at this yourself, everything's up on GitHub. We've got easy-to-use installers. Literally, it's just kind of run the command at the bottom, I think, for the client. Similar one for the server. It'll take care of all the setup for you. All the instructions and all the bits and pieces are up on GitHub. Don't forget, you'll need a Pi0W, and ideally you need some LEDs as well to get it running. But good luck.